Kirchhoff current law, KCL. KCL states a algebraic sum of all currents entering a node or a closed boundary is 0. We talk about a node here. If all currents, let's see, if all currents flow into this node, we sum them up algebraically, the sum will be 0. Or if we have a boundary, this boundary will cut any branches, cut this branch, this branch, this branch, this branch, and this branch. All these branches has a current flow into this boundary. If we sum them up, if we sum all of this current from all these branches that this boundary cuts, the sum is 0. So let's look at this more. So if I have this branch here, I1, I2, I3, up to I7, this branch can connect to other circuits, and this branch can connect to other circuits. Whatever it is, it doesn't matter. So we want to look at locally this node, and we want to look at the current flow into this node. When we talk about current flowing into or current entering a node, by default, we already talk about the current directions. Remember, when we talk about currents, two factors. One is direction, the other one is value. So KCL, when we talk about KCL, these two factors has to be defined clearly. In this case here, all this currents flow into this node, I1 plus I2 plus until I7, that equals 0. This is KCL. Please note that I1, the value of I1, I2 until I7, their values can be negative, but the directions are here. Current flow into the node. So we have plus I1 and plus I2 and plus I3 and plus I7, etc. and sum them up. The value of I1, value of I2, then all of this algebraically sum together will make 0. Okay. So if we using this summation here, I of k equals to 1 to big N, if there is n branches connect to this point, to this node, that equals 0. What about this currents has different directions here? So we have I1 flow into, I2 flow into the nodes, I3 flow out of this nodes, and I4 flow out of this nodes, and I5 flow out of this nodes, the same of I6, and I7 flow into the nodes. So now all of these currents have different directions. So we need to have signs between all of these currents. So we're going to define that the currents entering into the nodes has plus sign, and the currents leaving the nodes, flowing out of the nodes, have negative sign in front of the current. We will have I1, I2, and I7. They're all flow into the nodes. So they have plus I1, plus I2, and plus I7. And all of those other currents here, they flow out of the nodes. So they have negative, 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 and negative sign in front of each current that flow out of the nodes. So this is KCL as well. So KCL, you have to consider the direction of the currents, and then the value of all the currents algebraically, then the sum is equal to 0. That if we do a little reorganization here, move all of this I3, I4 to I5, I6 to this side, and we have this. So basically we have the current flow into a node is equals the current flow out of the nodes. Okay, so this is KCL. Let's look at example. Here is one node, all of this just one node. So we define I of t flow out of this node, and then everything else I1 here flow into this node, and I3 flow into this node, and then I2 flow out of this node. And remember, this is one node, so this is a one big node here. If we draw here, this is a big node here. L flow out of here, and then I have I2 flow out of this node, and then I have, this is a node I1, and then I have I3. KCL means that everything flow into, all the currents flow into the nodes equals to all the currents flow out of the nodes. So basically, which one is flow into the nodes? So I1 plus I3. What currents flow out of the nodes? IL plus I2. So IL equals to I1 plus I3 minus I2. This is exactly what obtained here. All of this can be simplified as one current here now. So this is A and B. This is the terminal connect to other circuits here, and then we don't know what is the connection here. But anyhow, this here, that's one point. That's one node. This node here, that's this node here. This node will have a current flow into A, terminal A or node A with I of t equals to this. The KCL help us to simplify the circuits here. There are connection here, there's connection here. There are two branches come out, one, 2, 3, and 4. Okay, going to draw a boundary here. Okay, so this boundary will cut this branch, this branch, this branch, and this branch. KCL tells us that all the currents flow into this boundary equals 0, which means that the currents flow into this boundary equals the currents flow out of this boundary. This is I here. So this is I. Let me cut it again. This is I. I's flow out of the boundary. 4A's flow out of boundary. And minus 3. You can see this is a minus 3. This is a, but it's a flow into, and 2A is flow into. Currents flow into is equals to 2A plus minus 3 equals to currents flow out of this boundary. That will be 4 and plus I. What is I? I equals, this is minus 1 and 4, that's minus 5.